Hello everyone, welcome to our lesson for today. Today, we are going to continue our discussion more on the arithmetic sequence. Get your notebook and your pen to take notes of the important details. Feel free to replay this lesson if there are things you do not understand. Okay, so let's start. Objective. At the end of this lesson, you will be able to find the sum of the terms of a given arithmetic sequence. Let us try to discover using summing up. What is the sum of the terms of each finite sequence below? Number 1, the sequence 1, 4, 7, and 10. What is the sum of all the terms? So to get the sum, you can easily add 1 plus 4 is 5. 5 plus 7 is 12. And 7 plus 10, 12 plus 10 rather, is equal to 22. Therefore, the answer here is 22. Now, in problem number 2, sequence 3, 5, 7, 9, and 11. What is the sum of the terms? Now it's your turn. I want you to answer. Let's check your answers. So 3 plus 5 is 8, plus 7 is 15. 15 plus 9, that is 24. And 24 plus 11, that is 35. So the sum of all the terms in this sequence is 35. Okay, now in problem number 3, what is the sum of the terms? 10 plus 5, that is 15. Plus 0 is still 15. Plus negative 5, that is positive 10. So positive 10 plus negative 10 is 0. So 0 plus negative 15 is negative 15. Okay, so the sum in this sequence is negative 15. Okay, now we used the concept of summing up in this activity. Now, do you know the story of the Secret of Karl? Okay, let me tell you, or let me ask you, what is 1 plus 2 plus 3 plus until you add 100? So Karl here was asked about this question. And this is a famous story that tells that this was the problem given by an elementary school teacher to the famous mathematician to keep him busy because he is too smart. Do you know that he was able to get the sum within seconds only? But how? Here's how we get the sum of the terms. Using the formula, S sub n is equal to n over 2 times the quantity 2a sub 1 plus the quantity n minus 1 times d, where S sub n is the arithmetic sum. N is the number of terms in the finite sequence. Why finite sequence only? Because obviously If it is an infinite sequence, then we cannot get the sum of all the terms because it is never ending. A sub 1 is equal to the first term, and as we all know, D is equal to common difference. Example number 1. What is the sum of the integers from 1 to 100? So what are the given values? N is equal to 100 because we have 100 terms in the sequence 1 to 100. A sub 1 is equal to, of course, 1. And then, what is the common difference? Madali lang. We all just have to add 1 to get the next number, tama? Because 1, 2, 3, 4, 5, and so on. That is how we count the integers. So therefore, the common difference is 1. Okay, now, using the formula of arithmetic sum, let us solve. So first, you are going to substitute all the values in the formula. So here, as you can see, we used S sub 100 because we are tasked to get the sum of the integers from 1 to 100. Okay? Now, so N here, substitute to 100. Okay? And then 1 is our first term. And then again, N is 100. And then what is the 1 here on the right side? That is our common difference, which is also 1. So now let us solve. If you find it difficult, you can use calculator. How do we use the calculator? Ilagay ang lahat ng numbers as it is. And do not forget to put the parentheses. Okay? So ilagay kung parentheses, parentheses. Kung dalawang parentheses, then dalawang parentheses. Do not forget that para hindi mali ang answer sa calculator. But if you will follow the long method, then let us try. So first, you follow the PEMDAS, parentheses. So here, let me erase this one first. Okay. Now, in the parentheses, let us solve first 100 minus 1, that is 99. Okay. And then 2 times 1 is 2. And then, in the outside of the parentheses, we have 100 divided by 2 is 50. Okay, so that's very easy. Now, next. So, again, what are the terms inside the parentheses? So, that is 99 times 1 is still 99 plus 2. So, we get 101. Copy 50. So, 50 times 101 is equal to 5,050. Therefore, the sum of the integers from 1 to 100 is equal to 5,050. That's very easy, right? Let's proceed to example number 2. Find the sum of the first 20 terms of the arithmetic sequence. 5, 9, 13, 17, and so on until the 20th term. Okay? So given n is equal to 20 because we are tasked to get the first 20 terms only. Now, a sub 1 given in the problem is equal to 5. And then the common difference, that is equal to, since we have the sequence here, so we can easily get the common difference. 9 minus 5 is equal to 4. 13 minus 9 is equal to 4. And so on. So the common difference is 4. Using the formula again of the arithmetic sum, S sub n. Solution, you substitute the values. Okay, let me explain here. So why S sub 20 again? Because we are solving the first 20 terms. So of course, n substitute into 20. And then where do we get 5? 5 is the first term. As you can see here, this is a sub 1. By the way, the operation between these two, 2 and a sub 1 is multiplication, okay? So, dili matingala why we put parentheses here because the operation is multiplication. Plus, again, n is 20. And then, where do we get 4? 4 is our common difference. Okay? Now, use the PEMDAS. So, 20 minus 1 is 19. And then bring down 4. 2 times 5 is 10. And then outside the parentheses, you divide. 20 divided by 2, that is 10. So, let us continue. 19 times 4 is 76. Plus 10, that is 86. And then bring down 10 here. So that our final answer is S sub 20 is equal to 860. Therefore, the sum of the first 20 terms of the arithmetic sequence 5, 9, 13, 17, and so on is 860. Now it's your turn. Now it's time to open your modules. Prepare yourself and get your modules and your pen. You can also use calculator if you find the numbers difficult to compute. Good luck!